The first thing you need to do is make sure that you have Python installed. For this tutorial, you'll be using Python 3.10. Once you have that dealt with, your next step is to install NLTK with pip. It's a best practice to install it in a virtual environment. For this tutorial, you'll be installing version 3.5 to create visualizations for named entity recognition. You'll also need to install NumPy and Matplotlib. By tokenizing, you can conveniently split up text by word or by sentence. This will allow you to work with smaller pieces of text that are still relatively coherent and meaningful even outside of the context of the rest of the text. It's your first step in turning unstructured data into structured data, which is easier to analyze. Here's how to import the relevant parts of NLTK so you can tokenize by word and by sentence. Now that you've imported what you need, you can create a string to tokenize. Here's a quote from Dune that you can use. You can use sent_tokenize to split up example_string into sentences. Stop words are words that you want to ignore, so you filter them out of your text when you're processing it. Very common words like in, is, and are often used as stop words since they don't add a lot of meaning to a text in and of themselves. Here's how to import the relevant parts of NLTK in order to filter out stop words. Here's a quote from Worf that you can filter. Now tokenize Worf_quote by word and store the resulting list in words_and_quote. You have a list of the words in Worf_quote, so the next step is to create a set of stop words to filter words_and_. For this example, you'll need to focus on stop words in English. Next, create an empty list to hold the words that make it past the filter. You created an empty list, filtered_list, to hold all the words in words_and_quote that aren't stop words. Now you can use stop_words to filter words_in_quote. You iterated over words_in_quote with a for loop and added all the words that weren't stop words to filtered_list. You used case fold on word so you could ignore whether the letters in word were uppercase or lowercase. This is worth doing because stopwords.words English includes only lowercase versions of stop words. Alternatively, you could use a list comprehension to make a list of all the words in your text that aren't stop words. When you use a list comprehension, you don't create an empty list and then add items to the end of it. Instead, you define the list and its contents at the same time. Using a list comprehension is often seen as more Pythonic. Take a look at the words that ended up in filtered list. Stemming is a text processing task in which you reduce words to their root, which is the core part of a word. For example, the words helping and helper share the root help. Stemming allows you to zero in on the basic meaning of a word rather than all the details of how it's being used. NLTK has more than one stemmer, but you'll be using the pointer stemmer. Here's how to import the relevant parts of NLTK in order to start stemming. Now that you're done importing, you can create a stemmer with pointer stemmer. The next step is for you to create a string to stem. Here's one you can use. Before you can stem the words in that string, you need to separate all the words in it. Now that you have a list of all the tokenized words from the string, take a look at what's in words. Create a list of the stemmed versions of the words in words by using stemmer.stem in a list comprehension. Take a look at what's in stemmed_words. Part of speech is a grammatical term that deals with the roles words play when you use them together in sentences. Tagging parts of speech, or pause tagging, is the task of labeling the words in your text according to their part of speech. Here's how to import the relevant parts of NLTK in order to tag parts of speech. Now create some text to tag. You can use this Carl Sagan quote. Use word tokenize to separate the words in that string and store them in a list. Now call NLTK.pause_tag on your new list of words. All the words in the quote are now in a separate tuple, with a tag that represents their part of speech. Now that you're up to speed on parts of speech, you can circle back to lemmatizing. Like stemming, lemmatizing reduces words to their core meaning, but it will give you a complete English word that makes sense on its own instead of just a fragment of a word like discovery. Here's how to import the relevant parts of NLTK in order to start lemmatizing. Create a lemmatizer to use. Let's start with lemmatizing a plural noun. Scarves gave you scarf, so that's already a bit more sophisticated than what you would have gotten with the pointer stemmer, which is scarve. Next, create a string with more than one word to lemmatize. Now tokenize that string by word. Here's your list of words. Create a list containing all the words and words after they've been lemmatized. Here's the list you got. Thanks for watching. Please check the another video, part 2 of this video, the complete NLTK with Python. Also all the sources linked below the like button. Subscribe to my newsletter.